So to kind of kick that off, I wanted to talk to you about grading just a little bit more. Your grades for the 5th 6 weeks report card got turned in by your teachers today at 10 a.m. So there's only one more grade that's going to go in for this semester, right? Since we're not doing final exams. And that grade is going to be your 6th 6 weeks grade. So this semester is either pass or fail, right? It's either going to say, yes, I passed and I got my pre-AP geometry credit, or no, I didn't pass and get my pre-AP geometry credit. I have to start over. I have to take the class in summer school. So I don't want anybody that's in here to have to do that for this class or any other class. So I wanted to talk to you a little bit about how to know what your teachers are going to be doing in order to determine that. So since there's no final exam, it's going to be kind of simplified. You guys can see my calculator now, right? Can you see the calculator right here?
Yeah, I can.
Okay, very good. So your report card grade is just going to say pass or fail, right? But your teacher's grade book is going to have a number in the grade book, right? So if your grade is 75, it's going to say that you passed. If your grade is 90, it's going to say that you passed. If your grade is 65, it's going to say F or fail. But there's still a difference between getting like a 65 and a 50, okay? There's still a difference between, not for GPA, but as far as determining your semester average. So let's say, hi Joelda. Let's say that your 4th 6 weeks grade was a 75 and your 5th 6 weeks grade, you slipped up a little bit and you got a 68. And you're like, oh no, I didn't pass 5th 6 weeks. What am I going to do? Well, if you get an 80, okay, that's the sum of your 3 6 weeks grades. There's no final exam, so all your teachers are going to do is divide that by 3. And as long as that average of your 3 6 weeks grades is going to come out to 70 or higher, then you get your credit. That's what you want, right? And then you might ask yourself, like, how do I know what grade I need to shoot for in order to get my credit? Not that you want to like just barely scrape by, but sometimes people like to know what they need. Okay, so this person, they got a 75 and a 68. What score do they need in order to pass and get their credit? Well, let's see. If they get 70, I think if they get a 67. 67, okay. If we divide that by 3, hey, that's a 70, okay. So this is the magic number. 210 is the magic number. When you add together your 4th 6 weeks and your 5th 6 weeks and your 6th 6 weeks grade, as long as the sum of those numbers is 210, then you're good to go. You get your credit. If you have questions for me about what your 5th 6 weeks grade is, if you can't get into focus, let me know and I can help you out with that, okay? So let's look at the calendar for this class and get a quick update of where we're supposed to be. So here, everything that we're going to use to get our grades this 6 weeks is going to be posted here in the 6th 6 weeks folder. And if I come down here, here's the pre-AP geometry calendar. So right here we are on April 14th. Here we are today. We're going to talk about quadrilaterals and coordinate algebra. So you should be done with both of these activities. I can kind of see how everything is set up on here. So for parallelograms, you got your warm-up, your instruction, your summary, and your assignment, and then you take a quiz. For the special parallelograms, same thing. So I'm going to assign you a grade in focus based on what your quiz grades are, right? It's going to give you a grade in Edgenuity for what your current course grade is right now, and that factors in, are you keeping pace with the schedule? Okay, once you start to fall behind this calendar, it's going to start to ding you points. So that should send off some alarms in your mind, like, hey, I need to get back on it. I need to redouble my efforts and get into some kind of a routine. I know that it's hard not having the bells ringing and teachers saying, get to class, go, go, go. But I'd really, really encourage you to get into a normal routine. Take some breaks and go outside. Don't just sit down at your computer for 10 hours, because then you're going to be a computer zombie. You know, go outside, take a walk, but get into a normal routine where it's like, I'm going to do my English at this time. I'm going to do my geometry at this time. I'm going to do my world geography at this time, so that you don't wake up one day and you're like, oh no, it's May 1st and I haven't done anything. I have to really get to it. So I can see y'all's progress. There are more people that have finished with this quiz, the parallelograms quiz, than the special parallelograms quiz. You're not going to get points off in the focus gradebook for not having those done by a certain time, but if you're falling behind in this class and you're also falling behind in your other classes, that's really going to stack up and it's going to put you in a situation that you don't want to be in. So if at any point you have questions about what you're learning in here that you want to reach out to me and talk to me about on email, or send me a remind message, I would be happy to help you with those. And then we'll go over the assignments to get you ready for the quiz during the Zoom class that we all have together. So before we look at that, do you guys have any particular topics or any particular problems from what you've been looking at in Edgenuity that you'd like to discuss? You can put a question in the chat if you're feeling shy using your voice. And once we get to where we're talking through some of these questions together, I'm going to be looking more for you guys. Like, you can hit the space bar to unmute yourself temporarily. I learned that last night. So you can hit the space bar and answer a question. You can answer a question in the chat. But I'm going to try to do more than just me talk for an hour, because that would not be really exciting if I was in your shoes, and I don't want you to be in that position. So I went through and looked at some questions on the assignments that I thought would be good for us to talk about, and here it is, and it's not opening. Whoops. Hold on for a second here. Maybe I need to, let me try to log back in. All right, we are doing this class. Okay, here we go. Open sesame. There we go. Okay. So if you had a particular question that you were wondering about in here, we can talk about those. If you wanted to follow along in Edgenuity, I would be totally fine with that. So we're going to look at number 2. And since we're kind of looking at the teacher notes right here, it's going to show us the answers. I'm not just going to say, hey, does everyone understand why the answer is? We're going to actually work it out. So this says use parallelogram A, B, C, D. What are the values for X and Y? So I'm drawing this out on a separate sheet of paper, and I'm going to switch over to the document camera here in a second. A, B, C, D. So it says that X is 17 and Y is 10. So what do we know about parallelograms that is going to help us solve this problem? This is where you can put it in the chat or unmute yourself and share your thoughts and beliefs about this with the class. I'm having more technical difficulties here. I'm sorry, y'all. I'm trying to show you the document camera. There we go, show all windows. So while I'm bringing this up, what thoughts do y'all have about what we know about parallelograms? What is, maybe a more specific question I could ask is, what is true about the opposite sides in parallelograms? Parallelograms are equal. Each side of a parallelogram is the same length. So when you talk about each side of a parallelogram being the same length, it's each of the opposite sides. Each of the opposite sides is the same length. Now, finally, you guys can see the document camera. Okay, good. So what it is that segment AB is the same as segment CD. Segment AD is the same as segment CB. So if we want to solve for X and Y, we can do 4Y minus 3 is equal to 37. So that's one equation that we're going to use to solve this problem for Y. To solve for X, we can do 3X minus 9 equals 42. And so now we just need to get X by itself and get Y by itself. So let's get Y by itself first. We can draw a line down the middle of the equal sign. We can add 3 on both sides. So that's going to give us that 4Y is equal to 40. The opposite of multiplying times 4 is dividing by 4. So that's how we get that Y equals 10. All right, and we need to do the same thing for X. This is 3X minus 9 equals 42. So we want to undo subtracting 9 first. The opposite of subtracting 9 is adding 9. So that's going to give us that 3X is equal to 51. That's 3 times X. So we can undo multiplying by 3 by dividing by 3. So that gives us that X is equal to 17. So that's how we end up with that answer that Y is 10 and X equals 17. So there were several problems on there that asked you to work out solving for a missing length. So this one is using the parallelogram diagonal theorem that they talked you through. And they want to know what is the length of segment EB in parallelogram ABCD. So there's some facts. There's some facts about the sides of parallelograms. What do we know about the diagonals of parallelograms?
Mr. Schaefer,
Yes.
the screen is just black and white lines. I can't see what you're looking at.
Oh no, well, that's not good. Can you see the document camera now?
Yeah.
Okay, there we go. So I'm gonna leave that last problem that we did. Sorry about that. Yeah, if you have technical difficulties, please speak up because I see something different than you see. Okay, so in a parallelogram, what do we know is true about the diagonals? What do the diagonals do to each other?
Well, why they bisect each other.
They bisect each other, that's right. So another way of saying that is the point where the diagonals cross is the midpoint of each diagonal. So let's look at what exactly that question is asking us to do. So we've got parallelogram A, B, C, D again. The midpoint for both the diagonals is E. So if E is the midpoint of segment BD, then we know that 2x plus 9 is going to equal the same thing as 3x minus 21. And so now that's a pretty simple equation to solve. So as we go through more of these, if we see equations like we've solved before, we'll kind of get started on how to set that up. This one's a little bit different than the one that we solved up above because we've got variables on both sides. So we have to decide, do we want to get the variables on the left side or the variables on the right side? It's going to be better on this one, I think, to get the variables on the right side, because if we subtract 2x on both sides, then that's going to give us 9 equals 1x minus 21. Then we've got a positive coefficient for x, and we're not going to have to worry about dividing by a negative number, which would just be an extra step to have to be cautious about and be careful on. So you can finish solving that one to get the correct value for x. I believe that's all that it's asking us for in that problem. Let's double check. No, it's actually asking us what is the length of segment EB. So let's go through all the way and finish that one off. So if we want to know what x is, the opposite of subtracting 21 is adding 21. So 1x is equal to 30. And for segment EB, which was 3x minus 21, segment ED was 2x plus 9. And since those are both congruent segments, it doesn't really matter which one we use because segment EB has the same length as segment ED. Well, if they want to know the length of segment EB, in terms of x, that's 3 times x minus 21. We solved over here and got that x is 30 because we know, hey, dividing by 1 isn't going to change anything, so we can just substitute right here. 3 times 30 minus 21, that's 90 minus 21, and that's how we get 69. That's how we end up with that answer of 69 units. So let's look at number 5. Number 5 would be really, really similar to the ones that we've already solved. You know that segment CF and segment ED are going to have to be congruent to each other. Once you set those equal to each other and solve for R, then they don't tell you the length of segment EF, but if you take the value for R and substitute it into the length for segment CD, the length of segment CD has to be the same as the length of segment EF. So you can solve that question pretty similarly to what we've done on the preceding problems. Okay, so what I wanted to talk about now was a proof, after I make sure this is very, very similar to what we did on numbers 2 and 3. Just be sure you draw out the picture and label the measures that they give you up here. Okay, number 9 is different. Number 9 is a proof. So let's think about what we know about parallelograms that can help us solve this problem. GHLG and GHLJ and GSTU are both parallelograms. And they want to know what the reason is that angle L is congruent to angle T. All right, so let's look at this sample response. By the parallelogram angle theorem, opposite angles of a parallelogram are congruent. Therefore, angle T must be congruent to angle G, and angle G must be congruent to angle L. So let's label that on the picture that we can make here. In a parallelogram, the opposite angles are congruent. The opposite sides are congruent, but we're worrying about the angles right now. So angle G is congruent to angle T in the smaller parallelogram. But angle G is also part of parallelogram GHLJ, so angle G has to be congruent to angle L as well. So that's everything that we have in the picture right now. All right, so it also says, by the transitive property of congruence, angle T is congruent to angle L. So what does the transitive property mean? The transitive property says that if A and B equals C, then A equals C. So when we were in class, we would always do this by talking about heights. If Aquila is as tall as Bianca and Bianca is as tall as Charlie, then Aquila and Charlie are the same height, right? So we could put it like this, that angle G, so they're saying that if angle T is congruent to angle G, but also if angle G is congruent to angle L, then angle T is congruent to angle L. So that's how you use the transitive property. So if we think about which of these facts about parallelograms we used in that answer, opposite angles of a parallelogram are congruent. Well, yes, because angle G and angle T were congruent, angle G and angle L were congruent. Angle T must be congruent to angle G. That's because of that opposite angles of a parallelogram are congruent fact. Angle G must be congruent to angle L, and therefore angle T must be congruent to angle L. So there's a look at a lot of the proofs that we did involved congruent triangles, but you can do a proof for just about any true statement in geometry. It doesn't necessarily only have to be about congruent triangles. So those were the problems that I had flagged as we need to talk about these parallelogram problems because they're kind of on the more tricky side. Do you guys have any questions about anything in the parallelograms lesson before we move on to some special types of parallelograms, rectangles and rhombi and squares? Any questions? I'm looking in the chat. Okay, could you, over the last problem? Oh, show the
Yeah, it
work.
did the thing. It
Did
did
it
the
do the
thing.
thing?
It
Okay.
did the thing. I just didn't want to interrupt you.
Hey, we're here to learn, and if you can't see, that makes it harder to learn. Can you see the document camera now?
I can, yeah.
Okay.
Apparently Kaylee can't see the whole thing.
Yeah, I'm chatting with Kaylee now.
There's like a square in the way. Like it's not, okay, wait. That fixed it.
Is that better? Okay. Good.
And now there's a square on the left side of the screen.
But it
Okay,
doesn't
okay. I know what's going on. It's because, is it gone now?
Yeah.
If I have the chat pulled up, that means that you can't see. I'm learning along with you guys. So if I have the chat up, I need to put it down at the
Leave
bottom.
that there's good.
Okay, there
Yeah.
we go. Okay, cool. So let's kind of, I'm going to leave this up, but also move over to some special types of parallelograms. What do we know about parallelograms? We reviewed that in a parallelogram, the opposite sides are parallel. The opposite sides are also congruent. And we also drew in the diagonals of a parallelogram, and we saw that those diagonals, this is not the world's most beautiful parallelogram, but we saw that the diagonals intersect and bisect each other. So this is a parallelogram. So the next activity was asking you to find important features of rectangles, rhombi, which is the plural form of rhombus, and squares. So what do you need to do to take a parallelogram and make it a rectangle? "90-degree angles." That's right. That's very good, Millie. So I can have a parallelogram with opposite sides congruent, but unless I have 4 right angles, that is not necessarily going to be a rectangle. But as soon as I have 4 right angles, that's enough to guarantee that I have a quadrilateral that's a rectangle. That's actually the simplest definition of a rectangle. It's a quadrilateral with 4 90-degree right angles. So since every rectangle is a parallelogram, that means that everything that we know about a parallelogram has to be true about a rectangle as well. The opposite sides are congruent and parallel. The diagonals bisect each other. And actually another fact about rectangles is that the diagonals are congruent. So if this is rectangle ABCD, then we would know that segment AC is congruent to segment BB. All right, what about a rhombus? What makes a parallelogram turn into a rhombus? What has to be true to be a rhombus? I'm going to draw a picture to jog your brains a little bit, maybe. A rhombus looks a lot like a diamond.
Yeah.
So what are the facts about this shape that make it a special parallelogram that's a rhombus? Congruent sides, 4 congruent sides, that's right. So whereas a rectangle has 4 right angles, a rhombus has 4 congruent sides.
And acute angles.
And when we draw in the diagonals, yeah, we're gonna have 2 acute angles, we're gonna have 2 obtuse angles. The diagonals are not necessarily congruent to each other, but they do intersect to make a right angle. This time the diagonals are perpendicular. Perpendicular. All right, and lastly, we have the square. So every rhombus is a parallelogram. Every rectangle is a parallelogram. The easiest way to think about a square is it's a parallelogram with 4 congruent sides and also 4 congruent right angles. So those are the facts that you're going to need to know in order to solve the questions that they're wanting you to be able to answer on the quiz over special quadrilaterals. So let's look at some of the questions from that assignment. From the shared application, can you guys see
The screen has,
you guys can see that what value of m would make parallelogram WXYZ a square?
No, it's showing those like weird lines again.
it did the black thing again.
Uh-oh. I'm sorry, y'all. Is that any better?
Now it's just black.
Okay.
The lines are gone, but now the screen is just black.
Okay, well, that's a step in the right direction, maybe.
This
I
is
don't know.
difficult.
I'm sorry, guys.
Nah, it's cool. Nope.
No. I'm trying an audible here. So we'll try sharing on the computer screen one last time, and then if that doesn't work, I'll just draw it up. Can you see
Sorry.
that? No, still no? Okay.
Yes.
Yes, you can see it?
Oh, I can. That's weird.
Yes for
I
some,
can. I don't know.
no
about
for others.
her.
So this is
It's
a,
weird how finicky it is.
yeah, I imagine that Zoom is kind of having a lot of bandwidth sucked up right now, so that might be a problem too. So we're going to look at this problem, and then I'm going to draw it out by hand, and we'll look at it on the paper too. It says, what value of x will make parallelogram ABCD a rhombus? And x is based on an expression that gives us the measure of angle AEB. So if this is a rhombus, what do we know has to be true about the diagonals of the rhombus? When they intersect, what kind of angle do you end up with?
Right.
A 90-degree right angle, that is correct. So that means that angle measure that they gave us in terms of x, 3x minus 12 degrees, that has to equal 90. So 3x minus 12 degrees is equal to 90 degrees. That's a fairly simple equation to solve. So now we can get it to focus. So the opposite of subtracting 12 is adding 12 on both sides. So now we've got 3x equals 102. We can divide both sides by 3. 102 divided by 3 is how they end up with an answer of 34 degrees. So that's an example of some more of those algebra problems. You just want to be sure that you know all those facts about rectangles and rhombuses and squares that we talked about. I want to spend the last 3 problems that we have to look at going over some proofs. So let's look at the kind of proof questions that they would want you to know about, and that's number 6, number 8, and number 9. So we've got a picture
Okay,
here.
so I can see the picture probably,
Mm-hmm.
but I can't see anything else.
But not the
Problem
text.
itself and the given.
So actually, I might like that better than
I
you
can see
being
the
able to-
given.
Yeah, because out on the side is the answer. So we're just going to talk through what that answer says. Maybe only seeing
okay.
the picture is that better, Akila? Can you see everything now?
Yeah, I can.
Okay. So ABCD is a square. That's what we know. And we're trying to prove that segment AC, the diagonal, is perpendicular to segment BD, the other diagonal. So they ask us to draw out 2 separate triangles, triangle AEB and triangle AED. So let's draw those triangles out. If you're working this out in your notes, you can draw both of those facing the same way, and then we're going to compare what our drawings look like together. So I'm going to do point A at the top, point E on the right, and point B on the bottom. And we're comparing that to triangle AED. Point A on the top, point E on the right, and point D on the bottom. Okay, so let's see what that looks like. Okay, so what do we know about a square? We know that in a square, all 4 sides are congruent. So that's telling us that side AB and side AD are congruent to each other, right? But additionally, we need to, the goal is going to be to try to show that these triangles are congruent to each other. Well, since every square is also a parallelogram, and since the diagonals of a parallelogram bisect each other, we know that side AE and side CE are congruent. We also know that side DE and BE are congruent. So that comes from the fact that this square has to be a parallelogram. But we also know that every square is a rectangle. What's true about the diagonals of a rectangle? The diagonals of a rectangle have to be congruent to each other. So if side A segment AC is congruent to segment BD, each of these halves of the diagonals have to be congruent to each other. We've got 4 congruent diagonal halves. So that means that side AE is congruent to side AE, and side BE is congruent to side DE. So what does that tell us? That tells us that these 2 triangles are congruent to each other. Triangle ABE is congruent to triangle ADE because of side, side, side triangle congruence. So what that's telling us is not only are all 3 pairs of sides congruent in these 2 triangles, but all 3 pairs of matching angles are congruent also. In other words, angle ABE has to be congruent to angle ADE. Those angles have to be the same. Angle BEA has to be congruent to angle DEA. And then when you look at the top, angle BAE has to be congruent to angle DAE. So the reason that is these 2 triangles, if they're congruent, are matching clones of each other, right? Every part of the triangles that match up has to be the same. It's like if you have 2 identical twins, right? They're going to have the same eye color, they're going to have the same right arm length, they're going to have the same left leg length. So the geometry term, the phrase that we use to say that any 2 parts of 2 congruent triangles that match up have to be congruent to each other is CPCTC. That stands for corresponding parts of congruent triangles are congruent. So what is that telling us? The whole goal of this problem was to be able to prove that the diagonals are perpendicular to each other. So if we know that angle, let's look back at what we've got here. We know that angle AEB, this angle right here, and angle AED, this angle right here, are congruent to each other. Well, those 2 angles make a linear pair. So the measure of angle AEB plus the measure of angle AED has to be 180 degrees. But those 2 angle measures are congruent to each other. So what's the only way that we can have 2 angle measures that are the same that add up to 180 degrees? It would have to be 90 degrees plus 90 degrees equals 180 degrees. So that's telling us that the measure of angle AED plus the measure of angle AEB, actually we don't want to add those, we want to set both of those equal to 90 degrees. Well, that's exactly the definition of congruent angles. That's telling us that those 2 angles have to be congruent to each other. So that's kind of a walk through a paragraph proof, being able to look at a problem and explain how you know that a certain fact is true. And I remember in geometry class, a lot of the times we would say, oh, I don't want to have to write out the statements and the reasons, and I don't want to have to fill in all those blanks. Well, this is kind of nice because it's not necessarily asking you to do statements and reasons. You're just explaining how you know each step. So we're almost up against it as far as time goes. We're going to look at one more proof. Do you guys have any questions over number 6 before we check out one more? So let's look at a proof for proving that a rectangle has congruent diagonals. This one does have statements and reasons. So let's go through and make sure that we understand what each of these statements and reasons is talking about. Okay. How do you always start a proof? If it's a 2-column proof where you've got statements and reasons, the first thing that you have to write down is what the given information is. So we know that quadrilateral ABCD is a rectangle. All right, so now they want us to draw segments AC and BD. So I'm going to draw this out on a separate sheet of paper and flip back and forth so that we can see what it looks like with the annotations in there, and we can see what the proof is looking like also. So we've got segment AC, we've got segment BD. So those are called diagonals. They connect the non-adjacent vertices of the rectangle. That's the picture that we're looking at right now. All right, so the whole goal for this is to be able to prove that those diagonals AC and BD are congruent to each other. So let's look at that. It's saying that angle BAD and angle CDA are right angles. Well, we know that that's true because we know the definition of a rectangle. Those are the 2 angles in the bottom left and in the bottom right. What do we know about right angles? Well, they measure 90 degrees. So any 2 right angles have to have the same angle measure. So that's step 4. Angle BAD is congruent to angle CDA because all right angles are congruent. Then in step 5, it's telling us that quadrilateral ABCD is a parallelogram. Why is that? Well, every rectangle has to also be a parallelogram. We can put that in conditional statement form as if a quadrilateral is a rectangle, then it has to be a parallelogram. So they put in step 6 that segment AB is congruent to segment CD. How do we know that? The parallelogram side theorem says that in a parallelogram, the opposite sides are congruent to each other. So the left side and the right side have to be congruent. Then they're saying that segment AD is congruent to segment AD. That's because of the reflexive property. The reflexive property says that you are congruent to yourself. It's saying that segment AD is the same whether or not it's part of the triangle on the left or whether it's part of the triangle that's on the top. So they're giving us a statement in step 8, triangle BAD. We're going to draw this out together and look at it. Triangle BAD is congruent to triangle DCB. So let's look at what that triangle looks like based on what they've told us so far. Well, let's see. We know that segment AB is congruent to segment CD. We know that angle BAD is the same as angle DCB. And we also know that segment DA is the same as segment CB. That's because of the definition of a rectangle. That's because of the parallelogram side theorem. And so now if you look at the congruent markings in these two triangles, we have a pair of sides that are congruent, a pair of angles that are congruent, and then a pair of sides are congruent. So that's SAS triangle congruence. So now that we know that these two triangles are the same, we know that any two matching parts of those triangles have to be the same. And that should be point A, I'm sorry, that's point A right there. That's triangle BAD and triangle ACB. No, that's still triangle DCB. We can also do this with triangle ABC. We could have the same statement between any two of these triangles. So if triangle BAD is congruent to triangle ABC, then we know that the matching hypotenuses have to be congruent. And so segment AC would have to be the same as segment BD. That's because those are two corresponding sides in two congruent triangles. So if this is true because of side angle side triangle congruence, then we know that segment BD is congruent to segment AC, and that reason is because corresponding parts of congruent triangles are congruent. So that's pretty much the full time that we had to talk today. Do you guys have any questions about this problem or about any of the other problems that you saw in parallelograms or special parallelograms on Edgenuity?
That I can think of.
Okay. Since we just got done talking about this, if you haven't knocked out both of those quizzes, I would highly recommend getting in there and doing that right now while this is fresh in your brain. I'm going to turn this into a YouTube video that you can go back and look at if you have any questions later on, or you can email me or remind me, and I'll be happy to help you out with anything that you're having questions about, okay?
Okay.
I'm taking one last look through the chat here. I don't know if I see any other questions. You guys stay safe, be healthy, okay? Let me know if there's anything that I can do for you. I miss
You too,
y'all.
Mr. Pinkins.
Thank you guys. Y'all have a good day.
You too.